We will do another problem on steady flow energy equation. Here, the problem is in a steady flow apparatus, 135 kilojoule of work is done by each kilogram of fluid. The specific volume of the fluid, pressure and velocity at the inlet are 0.37 meter cube per kilogram, 600 kilopascal and 16 meter per second. Okay. Again, this is a steady flow. This is a steady flow apparatus. So we will first draw it here. So here, so this is the inlet. Let us take this as the inlet, which is 1. So at this position, so here it is given 135 kilojoule of work is done by each kilogram of fluid. So that means there is a fluid that is flowing through that is doing 135 kilojoule of work. It is doing so that work will be positive because that is work done by the system. This fluid is our open system if we take that control volume. So here the specific volume of the fluid, pressure and velocity at inlet are, so it is given as 0.37 meter cube per kilogram, 600 kilopascal and 16 meter per second. So the inlet is 32 meter above the floor, okay, and the discharge pipe is at floor level. So the level is given. So this height difference is 32 meter. Okay, and discharge pipe is at floor level. Discharge conditions are 0.62 meter cube per kilogram, 100 kilopascal and 270 meter per second. So discharge condition is 0.62 meter cube per kilogram, 100 kilopascal and 270 meter per second. The total heat loss between the inlet and discharge is 9 kilojoule per kilogram of fluid. Okay, so the question they have asked, in flowing through this apparatus, does the specific internal energy increase or decrease and by how much? Okay, so here it is given that it is doing a work of 135 kilojoules. So the work done is equal to 135 kilojoule per kilogram. So let us assume that the mass flow rate is, it is not given. Let us take it as 1 kilogram per second, m dot. And see, total heat loss between the inlet and discharge is, so there is a heat, you are losing heat, so that, so Q is equal to 9 kilojoule per kilogram fluid, so it is 9 kilojoule. Okay, so now let us apply the steady flow energy equation here. So this is our steady flow energy equation, Q dot plus m dot h1 plus v1 square by 2g plus g z1 is equal to w dot plus m dot h2 plus v2 square by 2g plus g z2. So Q dot is equal to, see, we are splitting h1. This enthalpy can be written as u1 plus p1 v1, that is flow work, u1 plus flow work plus v1 square by 2g plus g z1, and w is equal plus m2 m into u2 plus v2 v2 plus v2 square by 2g plus g z2. So if you substitute the values, you will get minus 9 kilojoule plus 1 into u1 plus, so the pressure at the inlet is given, so that is 600 kilopascal. So 600 into 10 raised to 3, and specific volume is 0.37. So that is also written here. Plus velocity is 16 square by 2g. Okay, then so W is given as 135 kilojoule plus 1 into U2, you need to find out, and P2 etc. given, P2 and V2, that is 100 kilopascal and 0.62 meter cube per kilogram into 10 raised to 3 plus 270 square by 2g. So if you solve this, you will get it as minus 9. See, I have written kilojoule because we are calculating here. These are all in joules. Okay, these are all in joules. So minus 9 kilojoule minus 135 kilojoule plus, so it will be this quantity, and so this is equal to U2 minus U1 is equal to minus 20 kilojoule. Okay, you can convert this in terms of kilojoule. So on solving that, you will get it as minus 20 kilojoule. So you can see that internal energy decreases by minus 20 kilojoule.